everybody, welcome back to another video. This one is on the combination of properties of exponents. So this is like pulling all the properties of exponents together. Like with other videos, you can pause it and you can work ahead, and then you can unpause and see how you're doing. But this is really checking to see, do you know, do you understand, can you work with all of the properties of exponents, maybe all in one problem, maybe not. So on page 276, usually if you're in class, I would give you this as almost like a warm-up, tell you to work on this by yourself, and then ask you to check yourself and see if you did it right. To give yourself a check or a smiley face. See these little boxes over here? Check yourself, and then if you got it wrong, then you have an idea of what you need to spend a little bit more time on, what you haven't quite gotten yet, and try to check and see where your learning is. So that's what I would like you to do right now. Pause the video, see if you can fill these out, and then unpause the video, and then we'll check and see what your answers are. All right, the first one, we've got x to the a times x to the b. We're going to add those exponents, x to the a plus b. We can't combine a plus b, so we're just going to leave it as a plus b. So if you did a good job, you could put a check or a smiley face in this box. If you didn't get it right, I wouldn't put anything in the box. You could put an x if you really wanted to, but definitely make sure that this is correct. All right, and the second one, we've got x to the a over x to the b. We're going to subtract those exponents. So we've got x to the a minus b. Again, we can't combine a minus b, so we're just going to leave it as x to the a minus b. So if you got it right, put a check or a smiley face in this box. If you missed it, then you need to probably focus a little bit more on what do I do when I see division. All right, example 3, we've got x to the a times b. For example 4, we've got x to the a, y to the a. Example 5, we've got x to the a over y to the a. For example 6, we've got 1 over x to the a. And then the last one is just 1. I like it when those things simplify down to something so simple as 1. So nice, so neat. All right, so how'd you do? Are you getting good with these exponent rules? When I see multiply, I add the exponents. When I see division, I subtract the exponents. Things like that are going to help you in the long run, because you're going to end up with more complicated problems down the road on the ACT and things like that, that you need to make sure that you're good on. When I see things being divided or parentheses with exponents on the inside and on the outside, what do I do? If you've got these exponent rules in your head, it's going to help you out a whole lot. All right, so one of the things that I highly recommend doing, especially if you know your properties of exponents, is kind of do what you notice first. I do have a kind of a guideline here that I'm going to give you in a second, but use the properties that you know. As soon as you start looking at a problem, being, oh, I can do this and I can do this, and start working down to a single answer. So kind of like, how in the order of operations, there's a set pattern, a set way to do things. That's not necessarily true here. So it's one of those things where it's, as long as you're using the correct rule, the order in which you do things isn't super, like, we have to nail it down a certain way, so that you have a little bit more flexibility than with the order of operations. But you can't make up your own rules either. You can't just do whatever you want to. So you do have to know the properties and know them well enough to know what you're allowed to do. So I do have this rule of thumb. If you have something complicated inside the parentheses, do the inside first, then multiply the exponent that's on the outside. Work from the inside out. Sometimes that's going to be the easier way, but not always. It just kind of depends. Again, it's one of those, what do you see? What do you notice? What are you allowed to do? So just keep that in mind. So a lot of times what I'll do is we have like these two stages. We have a numerator and we have a denominator. We've got like an upper platform and a lower platform. And usually when I'm working with problems like this, I'll see, well, what can I do in the numerator? What can I do in the denominator? Kind of simplify each level. And then what can I do to bring them together? So that's kind of where I want you to at least start looking. So for number one, notice that in the numerator, I've got some multiplication, I've got numbers I can multiply, I've got variables that I can simplify their exponents by multiplying. So in the numerator, I have one idea. In the denominator, I have a different idea. I have parentheses with another exponent on the outside. I want to simplify that using a different property of exponents. And then I'm going to look at how can I pull these together. Okay, so for number one, I'm going to multiply the 2 times the negative 2 in the numerator, get negative 4. I'm going to do x to the third times x squared. I'm going to add those exponents and get x to the fifth. So I've simplified that numerator. In the denominator, I have these parentheses with this exponent on the outside. I'm going to multiply. So this is going to be 2 to the 1 times negative 4 is negative 4. X to the 2 times negative 4 is x to the negative 8. Now, because these are both negative exponents and these guys are happy up on top, I'm just going to move these guys up. So I can kind of get rid of that denominator idea by moving my negative exponents up to the numerator. And then I'm just focused on one level. So I've now created it to where there's no fraction. And these are all different ways to do things. If you wanted to do it a different way, you could. But you'd have to still obey the properties of exponents. I'm going to figure out that 2 to the 4th is 16, and I'm going to go ahead and add those exponents on my x's. So x to the 5th and x to the 8th, 5 plus 8 is 13. And then the last thing I really need to do is I need to multiply that negative 4 times 16 and get negative 64, x to the 13th. And that's my final answer. Everything's been simplified. Now, if you saw something else could be done and wanted to do it, go for it. But again, it's not the order in which you do things necessarily. It's kind of what are you allowed to do and can you do that? So on number 2, you have a couple of options. You could go ahead and multiply everybody's exponent by 4, or you could actually combine these p's since they have the same base by adding their exponents and then dealing with the 4. So you've got some options. That's what I want you to start thinking about. So let's see what I did. I went ahead and multiplied. So I did 3 times 4 is 12. Negative 5 times 4 is negative 20. Now notice there's not any parentheses here. So this negative 4 is only on the p in the denominator. So there's not really anything to clean up here. There's a 1 in front. 1 divided by negative 2 is negative 2. So that's not going to simplify or clean up any at all. The exponent on this negative 2 is 1. So because this is negative doesn't mean that it's going to move. So the negative 2 is going to stay in the denominator. I really have to worry about cleaning up all of these p's. I just need one variable that's a p in my answer. The negative 2 will definitely be in my answer, and it'll be in the denominator. So what I can do is I can go ahead and add 12 plus negative 20 is negative 8. And then I can worry about moving things around. Looks like I moved my p to the negative 8 to the denominator and my p to the negative 4 to the numerator. You could do that. You could do negative 8 minus negative 4. You could do that. I think I ended up doing 4 minus 8 is negative 4, and that means that it stays on the bottom. You can think that this is 4 p's on top, 8 p's on bottom, and what cancels. But definitely, since these guys are going to reduce and be left in the denominator, you have to have a 1 on top. Remember, there's something that has to be always be in the numerator. And if everybody leaves, everybody's in the denominator, there's a 1 in the numerator. All right, let's look at example 3. We've got parentheses everywhere, and there's negative 2's. So no variables in number 3, so that's not too bad. So I'm going to work on the, let's see. We'll work on the numerator. No, I didn't work on the numerator. I did multiply here and get -6. And here I got 4. These all do have a base of -2, so I could have just kept them as -2s and dealt with stuff, but I think I'm going to end up moving this to the numerator, this -2 to the -6, and the -2 to the -3 to the denominator. Okay, and then -2 to the 6 is, oh, okay, so I subtracted. 6 minus 3 is 3. That's what I did. But I could figure out what -2 to the 6 is and what -2 to the 3rd is. I could figure out all those things. So this is just a different way. -2 to the 3rd is -8. -8 divided by 4 is -2. So if I did, and I kept this as -2 squared, right? That's what this was. If I did 6 minus 3 is 3. 3 minus another 2 would be 1. So this is -2 to the first power. So it's a different way of doing the same thing. So it's one of those, what do you see? What can you do? Kind of ideas. And there's more than one path to take. But like I said, if you see division, you can't add the exponents. That's not a rule. Okay, you have to follow the properties of exponents. All right, number 4. I've got some parentheses in my numerator. I also see this x is 0. I'd probably like to get rid of that. There's not a whole lot going on in the denominator, but I will be able to probably combine some of the stuff in the numerator and the denominator. So let's see what I did. Oh, I got rid of the x to the 0. Love it. Good job. And then, okay. So I went ahead and took care of this exponent being raised to the 5th. I multiplied. And you have to remember, here nothing changed. This is a -1 to the 5th power. That ends up being y to the 10th and z to the -10th. And then I want to kind of clean this up. Now this is -1 to the 5th power. That's going to be a -1. And I already have a -1 in the denominator. So I'm going to end up with a negative divided by a negative. That's going to end up being a positive in my coefficients. Let's see. Y to the 8th, I added -2 and 10 is 8. I did my adding in my z's, so z to the 3rd and z to -10th is z to -7th. And then I'm probably going to work with, so it's kind of like I simplified the numerator. There wasn't really anything to simplify in the denominator. Now I'm going to bring them together and see what can I do to simplify them together. So I know I'm going to do this -1 divided by -1 is going to be a positive. My answer is going to be a positive fraction. 8 minus 3 with my y's is y to the 5th. My x squared is going to stay in the denominator, and then the z to the -7th is going to move to the denominator as well to become a positive exponent. And that's all I can do. I have one of each variable. All right, let's see. Example 5. Not a whole lot to do in the numerator. But I probably am going to, and some of this, you hear me planning out loud. A lot of this, you're going to have to come up with a plan. So I'm probably going to clear up these parentheses in the denominator. Maybe move some stuff, or at least combine the denominator down, and then look at bringing my numerator and denominator together. So, yep. So my numerator stays the same. I did -2 to the -4th, a to the 8th, b to the -16th. I'm just multiplying everybody's exponent by -4, c to the -20. And then, let's see. Okay, all my negative exponents. So this -2 to the -4, I moved to the numerator. There's my a cubed. Here's my a to the -2. It went up and became a squared. So I'm moving all my negative exponents. There's b to the 5th, that stayed. B to the -16th went upstairs. C to the -20 went upstairs. The negative that was in front of that, a to the -2 stays. A to the 8th stays. c to the fourth stays. And when I say stays, I mean stays in the denominator. And then the c to the negative 2 move to the denominator. So that's what I chose to do, was get everybody with positive exponents. So now I don't have to worry about negative exponents anymore. Negative 2 to the fourth power is going to be 16. A to the fifth, 3 plus 2 is 5. B to the 21st, 5 plus 16 is 21. C to the 20th, and then negative 8, A to the 8th. Negative A, 8 to the I can't talk. Negative A to the 8th. There it is. Maybe. There we go. And then in my denominator, I have c to the fourth and c squared. I added their exponents, and it's c to the sixth. And then now I'm going to worry about pulling those two fractions together. Now, I don't have any b's in the denominator, so that b to the 21st is going to stay. I might do, instead of 16 divided by negative 1, I might write that as a negative 16. We'll see. But we do have to combine our a's. We have to combine our c's. So, yep, I did 16 divided by negative 1 is negative 16. My b to the 21st still is in the numerator. A to the third is in the denominator because 5 minus 8 is negative 3. And that negative on that exponent moves it to the denominator. C to the 20 minus 6 is c to the 14. And I have one of every variable. It's possible to, like, especially if you have a variable to the 0 power, it's possible to lose a variable, but you shouldn't have more than one of each variable. All right, let's look at number 6. Definitely can clean up the numerator some. I may put the p's together and the q's together. In the denominator, I'll probably take care of that multiplying the exponents by negative 4. So let's see. Yep. So 2 times negative 2 is negative 4. And then I've got p to the negative 2 and p to the negative 2. When I add those, I get p to the negative 4. On my q's, I've got q to the 4 plus negative 4. That's q to the 0. Now that's probably, I'm going to mark that out. I don't need that anymore. And if I was writing this out for me, like not teaching, but actually like working this out, I probably would not have even written q to the 0. I just know that it's a 1 and, you know, one less thing to write. R to the negative 2 is not going to move either, or it's not going to simplify. We will move it in a little bit. All right. In the denominator, I raised everything to the negative 4th power. So, oh, I lost a negative here. There should be a negative on that. Negative 1 to the 4th. It's going to end up being a 1 anyway, so I probably don't need to worry too much about it. P to the negative 20, Q to the negative 12, R to the negative 16. All right, so, yep, got rid of my Q to the 0. I just rewrote everything without Q. And then I probably about to rearrange everything. The only thing that's not going to move, again, that 1 that was here should move to the numerator, but it's not going to have an effect on anything. I'm probably going to rearrange everything to where there's not any negative exponents. Yep. So P to the negative 20 went up to the top. Q to the negative 12 went up to the top. R to the negative 16 went up to the top. P to the 4th went to the bottom. R squared went to the bottom. That negative 4 is just going to stay on top. And then I'm going to subtract 20 minus 4 on my P's, 16 minus 2 on my R's. Q has nobody to combine with. So I've got negative 4. P to the 16th, because that's 20 minus 4. Q to the 12th. 16 minus 2 is 14. So that's going to be it for that one. One of each variable. We also have a coefficient. Everybody's in the numerator. Everybody's got positive exponent. We're done. All right, let's see what else we got. Oh my, they're getting more and more complicated. All right, so number 7. We may try, let's see what I ended up doing. Okay, so I went ahead and took care of this -1 on the exponent. I multiplied everybody's exponent by -1. So I got 2 to the -1, x to the -2, y to the 4th, z to the 4th. Everything else stayed the same. I could technically put my y's together down here if I really wanted to, but I guess I didn't notice it. Again, it's like, what do you see? What do you notice? All right, I moved everybody with a negative exponent. Now that's 2 to the -1. I moved to the denominator. That negative was already there. So I kind of joined them up a little bit, but that's still going to be -2. All right, x to the -2 went to the denominator. The y to the 4th was in the denominator. This y to the 4th was in the numerator. Z to the 4th was here. I moved this x cubed up, this y up, this z to the -5 up. And then I probably will work on simplifying. Let's see the inside. Nope, I didn't do that this time. Normally, I probably would simplify the inside, but I went ahead and multiplied everything on the outside, everybody by the exponent on the outside. So I multiplied the 4 times 3, the 4 times 3, 3 times 3, 1 times 3, 5 times 3. -2 technically should have parentheses around it. To the 3rd, x to the 3rd, y to the 12th, and then started combining things. So y to the 12th and y to the 12th, 12 minus 12 is 0. So, and then I've got this y cubed. So there's that. 9 minus 6 is 3. And then 12, z to the 12th and z to the 15th. 12 plus 15 is 27. And then -2 cubed, even though it should be in parentheses, the parentheses wouldn't make much of a difference because it's an odd exponent. So it'd be negative anyway. But it stays in the denominator. Everything else kind of cleared up to the numerator. All right, let's look at number 8. Number 8, definitely going to get rid of that x to the 0. Probably going to put stuff in the numerator together and work in that denominator, multiply everybody's exponent by 2. Let's see what I chose to do. Yep, got rid of the x to the 0. Looks like I moved this negative. So it's a -1 times 2. That's -2. Did that. Everybody else did the same in the numerator other than that. And then here I did multiply -2 squared. I didn't remember my parentheses. 2 times 2 is 4. 2 times 2 is 4. Let's see what I did next. Okay, then I combined. In the numerator, I combined. I have -2 x to the 4th, but then I put my y's together. So -1 plus 5 is y to the 4th. And then z squared and z squared is z to the 4th. And then I multiplied everybody's exponent by the 5 on the outside. So it's -2 to the 5th, x to the -20, y to the 20, z to the 20, -2 to the 10th, x to the 20, y to the 20. And then -2 to the 5th is 32. -2 to the 10th is 1024. I could have, since these have the same base, I could have subtracted their exponents, but I didn't. That's okay. Looks like I moved this x to the -20 down to the denominator. So there's 2 of them in the denominator. All right, 32 over 1024 is 1 over 32. The y to the 20 over y to the 20, 20 minus 20 is 0, so there's no y's. X to the 20 stays on top, and then z to the 20 stays on top. X to the 20 and x to the 20, add those exponents, x to the 40 in the denominator. So I could have written z to the 20 over 32 x to the 40. That also would have worked. All right, so these are just kind of some big problems to where it gives you a chance to use all your properties of exponents and practice with them. So I'll see you in the next video.